What we're going to be doing in this experiment is we're going to start off here with the distilled water, and we'll take a measurement here and verify where we're at, where the plates are currently. We're going to execute the test, and we're at 135.3469 kiloohms. At this point in time, we're going to add 35 grams of instant ocean. This will give us the approximate salinity of what actual ocean seawater would be. Now, the material's a little bit chunky and the water is a little bit cold, so only so much of it's going to dissolve, but we'll see what we get here after we can get this dissolved as much as possible and the plates put back in. Further on in the test, we're going to use a piece of teflon wire, actually two of them, twisted together to make a simulated twisted pair. This is a mill standard Teflon silver plated conductor. It's a pretty good wire, and it has excellent electrical properties, and we're going to allow it to be a simulated wire run inside of a cable that is flooded out with the mixture that we're making currently. Okay, there's a little bit of residual salt in the bottom, and this is just because the water's not warm enough, and it's just we're at the point where there were some big clumps in the cup when I put it down in there, so it didn't fully dissolve. Our plates are approximately where they were before, and we're going to take a look and see what we have for a resistance reading between. There's the previous reading on the screen, and we'll take a hit retest here and see what we get now. Okay, we're looking at 8.79, roughly 8.8 ohms, and this is with the plates approximately 4 inches apart and approximately 6 square inches of surface area on each plate. What we're going to do now is we're going to add 10 grams of sap. Now, in the previous experiments, 10 grams of sap into the salt water is not really going to do a whole lot. We should not see any reaction with the sap. It's going to just be like it was before. In previous experiments, the sap will pretty much be a colloidal suspension, and that's all that should happen here. Once we get this stirred up real good, we're going to take a measurement and see what reading for resistance between the plates now. Okay, there's the previous reading, and that's the current reading. We have a little bit of a drop. Now we're down to approximately 6.8 and some change ohms. So the sap actually, being a salt, made it a little bit more conductive. At this particular point in time, I've allowed the sap to go ahead and sit for about 5 minutes or so. What's pretty much happened is, like before, sap's acting like a colloidal suspension. It's settling out on the bottom, and we're going to go ahead and take a look and see what the reading is now. And this is just, the readings actually went down a little bit, just a little bit from what it was previously, on account of the material is bridging the gap between the two plates better. What we're going to do now is we're going to put in, right here you can see the nick in the wire, the silver in the green area. This is the silver wire, what I was talking about, that we're using as a simulated twisted pair conductor run in a cable. And what we're going to do here is do some measurements and see what we can find with the wire. And currently I'm tracking down, just trying to find which wire is the bad wire here out of the pair. Okay, I've checked the left wire, and our left wire is the one that is showing resistance. And then we're going to go ahead and check the right wire, and that one is indicating an open. Now, in this particular cut now, what we're going to do is we're going to set up our test equipment, and we're going to do a low voltage insulation resistance and see just how the two wires react, the one with the nick and the one without the cut in it. Okay, this one here is the right wire, and it happens to be the good one, and we're testing at 100 volts with a 1 meg passing specification, and currently it's reading greater than 500 gigohms. I'm going ahead and I'm going to switch the wire, the lead to the left wire. This is the one with the nick in it that you can see is the silver. And we'll take a reading here. It's failing at 5 volts. I'm going to go ahead and turn down the pass-fail specification. And we're going to dial this down, and we're going to go to 100 k-ohm, in which it should still fail. And here again, we're failing at 5 volts. And that's 5 volts DC is where it's saying that it's definitely a fail. So our next point here is we're going to go ahead and hook up the LCR to the bad wire and see what our resistance reading is. Okay, when we test it, we're getting almost 62 ohms. So this is in the nick and the insulation, as you'll see here as we're going to get down and zoom into it. And it's kind of close to the plate, but it's just this little teeny nick. And this is going through, and this is with 10 grams of sap. And between it and the salt water, that's what it's currently reading, is approximately 62 ohms. What we're going to do now is we're going to go ahead and add 50 more grams of sap, in which I have, and I've allowed this to take and gel up, and that's what you're seeing there. And we're just going to go ahead and take a reading between the plates and see what we see now. Now with 50 additional grams, this is 60 grams of sap, and that's what we found out that would take for the whole solution to become jellified when it's in salt water. And we're reading 4.634 ohms of resistance between the two plates. So this is, and here we're cycling the reading a little bit, just to make sure that we pretty much have a stable reading. And this is indicating that we actually have more salt in solution as a result of the sap above and beyond what the original saltwater solution was.